Okay, this mini lecture is talking about Bayes' theorem. So Thomas Bayes was born around 1701 and died in about 1761. So he was a mathematician who created this theorem. So Bayes' theorem is the probability tells us the probability of event A given that event B has subsequently occurred is given by the formula. All right, this is a formula that you were probably given in your math course. So the probability of event A given that event B has subsequently occurred is given by this theorem that the Reverend Thomas Bayes came up with. Right? It's a really formidable expression, but we can simplify its calculation by going through what we're going to do in the example. So we're going to look at the following example on the next page of this mini lecture, and it's going to illustrate the use of Bayes' theorem. Right? So we go to the next page. So here's our example. It says in Calculus County. Wow, that's funny. In Calculus County, 51% of the adults are males. One adult is randomly selected for a credit card usage survey. Right, so all the information they give us. And on the right-hand side, they also state that for Part A, we want to find the prior probability that the selected person is a male. So once again, that's find the prior probability that the selected person is a male. Part B says it is later learned, so this is where you know Bayes' theorem comes in. It is later learned that the selected person was a cigar smoker. Also, 9.5% of males smoke cigars, whereas 1.7% of the females in that county smoke cigars. Use this information to find the probability that the selected person is a male. So you can pause this and copy this problem down as well as parts A and B. And now we'll move on to the solution. All right. So here's our solution. So first, let's use the following notation. Let's say that M stands for male. All right, let's say M bar, or you could even say M prime, depending on what your professor has told you, stands for female, right, or not male. Let's say C is equal to a cigar smoker. Oops, sorry about that. Cigar smoker. And let's say C bar, or you could use C prime depending on what you do in your class, is not a cigar smoker. Right? So C bar and M bar are complements of the other events. Cigar, not a cigar smoker. Alright? So before using the information given in Part B, we knew that only 51% of the adults in Orange County are males. So there's our answer. So the probability of randomly selecting an adult, and getting a male is 0.51. Easy enough. So now we move on to Part B. Based on the information, the additional information given, we have the following. Right? We have the probability of a male is 0.51. Right? The probability of a female, so M bar, the complement of the male being M bar the female, is 49%, 49 hundredths. And this is because 49% of the adults are females, not males. Right? And then we can say this, the probability of cigar smoker given M for males is 0.095. 0.095, right? Because 9, if you read part B back in the problem, it said 9.5% of the males smoke cigars. So that is the probability of getting someone who smokes cigars given that the person is a male, right? Someone who smokes cigars given that the person is a male is 0.095, and this was stated in the problem. And next is the probability of C given M bar. So this is 0.017, right? Because 1.7% of the females smoke cigars, and this was given in on the last page, right? That is the probability of getting someone who smokes cigars, given that the person is a female, is 0.017. All right. So let's use some more paper. You can pause this and copy down if you like. So we'll go to the next page. All right. Here on the next page, we're going to now apply Bayes' theorem using the formula that I wrote down earlier that you saw at the beginning of this mini lecture. And we're going to use M in place of A, right? The formula had A's and B's. So we're going to use M's, and we're going to use C in place of the B's, right? So our formula should look like this. The probability of M given C, right? Oops. Let's fix that up a little bit. So the probability of M given C. Probability of males given that they're cigar smokers. Alright, so using M's for C's, all I'm doing now is just replacing the A's and the B's that are in the original Bayes' theorem. That's all I'm doing. So we should get P M times pre C given M, and that's all divided by, let's see, it says P M times P C given M. Okay, and then you add that to P, PM, oh, I changed the color by mistake, sorry. PM bar times P C given M bar. Right, so I just replaced the A's and B's with what we're using, M's and C's. So now that gives us, once we plug in all the numbers that we already have, is 0.51, and this is being multiplied times 0.095. 0.095. And then all of this is divided by, let's see what we have, 0.51, right, times 0.095. Oops. Let's clean this up a little bit. Oops, sorry about that. Let's keep going. 0.095. This is a 5 right here. Alright, and then we are to add that to 0.49. change the color, but that's okay. And multiply that times, let's see, what's the next value? 0.017. Alright, you punch that in your calculator correctly and you should get 0.853. Alright, so before we knew that the survey subject smoked a cigar, there was a 0.51 probability that the survey subject is male, because 51% of the adults in Calculus County are males. However, after learning that the subject smoked a cigar, we revised the probability. We revised that probability to 0.853. So there is a 0.853 probability that the cigar smoking respondent is a male. This makes sense because the likelihood of a male increases dramatically with the additional information that the subject smokes cigars, because so many more males smoke cigars than females. So it makes sense. So you think about that and you would say, okay, let's go ahead and box this in. Alright, so that's a small brief example of how to use Bayes' theorem. And this is a mini lecture talking about Bayes' theorem. The Reverend Thomas Bayes is the person who created it, and he was an English minister and mathematician. Although none of his work was published during his lifetime, later publications included the following theorem, or the previous theorem that we just went over actually, or rule, as some would call it, that he developed for determining probabilities of events by incorporating information about subsequent events. So that's the key word. Thank you.